Well, you don't have to read it for like 3 minutes. You have to shove it in. So 13, right? No? I didn't. Can I write this one? Yes. Okay. 13. When solid ammonium chloride is put in a reaction vessel at 323 Kelvin, the equilibrium concentrations of both ammonia and hydrogen chloride are found to be blah blah blah. Given the equation, blah blah blah, what is the KSB value? Okay? So, first thing to do with this, because we were not given enough information, we have to find some information from it. So remember our ice charts? So what we're going to do,
What information are we missing?
we have enough information in regards to concentrations in order to put it into a formula.
Are you sure? What do you mean concentration?
We only have
Like the
Values.
moles per liter?
Yeah.
But it says it's for mercury.
So not relevant.
Oh, like degrees.
Sure.
So quick reminder, ice,
Oh, this.
that's how we get them. Initial, change, equilibrium. So that's how we get that. Okay? So, you're going to have a chart here. It's going to be hopefully neater than mine.
This is the one
Okay?
that don't know how to do.
So, we look at this and let's think about the items that we know and what we don't know. We were told that the equilibrium concentrations of both ammonia and hydrogen are 0.0660. So, am I putting that under initial, change, or equilibrium?
Initial.
There we go. Equilibrium concentration, so we get to just plug it right in equilibrium this time. So, you're going to put it here.
Wait, why would you need in there? Because it says equilibrium concentration. Okay.
So I'm just gonna write it sideways just because I give myself enough room here.
It goes with all three of them?
Well, we only know about the two currently. Right? We were told about ammonia, which is NH3, and we were told about hydrogen chloride. We know those two. So let's just stop and think about this for a second. So initially, there's no products made, right? So this is going to be a zero. Right? Okay. Now, there's another way to look at it, and I'm going to show it to you just because some people find it easier, and I don't think I had shown it to you earlier, so I'm just going to show this comparison to you guys. If we compare either one of them to the NH4 Cl, so I'm going to just choose hydrogen chloride, okay? It's a 1-to-1 ratio, right? If you're looking at the equation. You see that? Okay. So, if we say that it's a 1-to-1, I don't know what this one is, but I do know my equilibrium value here, right? That we had found. A little bit, we're told, I should say. Are you okay with this? What I'm saying right now? So if this is a 1-to-1, what is my x going to be? It's going to be the same. So I don't have to do any more calculations or whatever. I can just plug this number in. Okay? And so for some people, and I apologize I didn't show you this earlier, some people find this an easier route to look at it.
So if it was a 2-to-1 ratio, we would multiply it by 2.
Right. So
What the NH3, or is it just the HCl and water?
you could have compared it to NH3 instead.
It's just comparing to one of them?
Yeah, comparing to one of them because there's only one reactant. Yeah, so if you're comparing the other one. So we now have equilibrium values, okay? So when we are dealing with our question, remember that our formula KSP is that products divided by reactants, right? Now, what is my equation going to look like without putting numbers in? Just the formula at first. What am I putting up? NH3 and then HCl. And we don't put anything at the bottom, and why don't we put anything at the bottom? Solid. So technically we did extra work here to find that equilibrium value. Didn't need it, but I just wanted to show you in this other form so that you can see how to solve for it, okay? So this is what I'm doing. So now what am I going to do? Put the numbers in, okay? So remember that because my coefficients were 1, my exponents would be 1, so I don't have to do anything. So I'm just going to go my 0.0660 multiplied by my 0.0660. As long as I didn't make a mistake when I was doing my math here. That would be my answer. Do I need units? No. And that's it. Okay, so that's 13.
So, I don't see what's the part of the chart.
So in this question, we wouldn't have had to do the chart, okay? But I wanted to show it to you one time, at least to show you this example, just to see if some people found it easier, so then I would continue showing this example for the next one. For this question, in the end, you don't have to do a chart. And the reason why you don't have to do the chart is because this NH4Cl is a solid, and that was my only unknown, right? You didn't know what it was? So then I didn't need it in this equation.
So, like, if you do the 1-to-1 thing,
This one-to-one aspect was to find out about NH4Cl. So I wouldn't have had to do any of this for this question. I could have strictly just done this. Okay? I just wanted us to go over this because I know that when we were working on it, we had trouble with ice chart. So I wanted us to practice on it. Okay?
what if the NH4Cl was a gas? Then
So if NH4Cl was a gas, then you would have had to do this chart to find out what this value was here. Then because you have this value, remember that it would have been divided by it,
oh yeah.
and we would have divided it out and had a different answer. Okay? Does that make a little more sense? Okay, we're going to move on to 14. So the Chavier's principles predict how each of the following changes would affect the equilibrium. Okay, so if I added H2O to the system, Jeremy, is H2O on the reactant or product side? The 14A? Sorry?
Slow.
Product? Okay, so I'm going to be, when I say adding, is that increasing or decreasing, Melissa? So I'm increasing my product. So which way is it going to shift? Okay, that just means therefore. Which way is it going to shift, Lily?
That way.
Which is left. Shift to left. Again, we okay if I do short form? L for left?
Okay.
Alright, are you okay with A? Removing CO from the system. Okay, so CO is that a reactant or product, Darcy?
Product.
Okay. When it says removing, what does that mean? Increasing, decreasing CO? Okay. So Brooklyn, what's going to happen now?
Shift to the right.
It's going to shift to the right. Okay, and remember, because we decreased the product, it means that there's a bunch on the reactant side, right? So it's going to try and balance it out. That's why it shifts to the right. Looking at C, H2, where do I find that, Carter? Is it a reactant or a product? Sorry, I'm deaf.
Yeah.
Good job. 14, when it says adding, is that increasing or decreasing? Okay, so what's gonna happen, Emilio, is they're gonna shift to the right or to the left? Use a little chart for yourself. So the chef used charts going with all the temperatures and concentrations and stuff.
It's gonna shift to the right.
Okay. Alright, so adding something to the system to absorb CO2, what does this mean? Anyone? CO2 is decreasing. And is my CO2 a reactant or a product? Okay, so decreasing the reactant, when that happens, which way is it going to shift? Bailey? Okay. Decrease the reactant. So when you're absorbing, when you absorb something, like take a sponge, absorbing water, it's taking water, so it's taking it out. So it's removing it.
But how do you get that looking in the chart?
I have shifted, right? Or decreasing of reactant?
Yeah.
These are pressures?
Oh,
I was not aware of that. Wait. So, moving on to 15 then. So ethylene, C2H4, which now that you've done organic, you probably should have been able to think it up yourself. Reacts with hydrogen to form ethane, C2H6 plus heat. Write a balanced equation to show the equation. How would you regulate the temperature of this equilibrium in order to do the following? So, first things first, we have ethylene that's reacting with hydrogen. Remember that my hydrogen has to have a little 2, and why is that? Diatomic. Good. Okay. And it is making me C2H6. And someone help me out with the balancing. Good. Wait. So before we start anything, is this exothermic or endothermic? Exo? And how do we know it's exo again? Because it's leaving or exiting, so exothermic, heat's given off, so it's on the product side. Okay? If it wasn't on the product side, and it was delta H given to us, right, in this form, how would you see that value? The negative. Right? Okay. So, we wrote a balanced equation, okay? Now it's saying, how would you regulate the temperature of this equilibrium in order to do the following? So, if I wanted to increase the yield of ethane, is ethane a product or reactant, Max?
Ethane is not a reactant.
Yeah. Right. So I'm increasing the product. So normally if I'm increasing the product, which way is it going to shift? Okay, so it's shifting to the left. In order for us to regulate it and to get it to go back so that it stays at equilibrium, I need it to shift to the right in order to counteract that, right? Is it shifted to the opposite way? So how am I going to get it to shift to the right? I would decrease the temperature. So I'm going to decrease the temperature because it causes the shift to the right. And if I shift left and right, I'm balancing it out. Are you okay with that? on to B. Decreasing the concentration of ethylene. Ethylene is either a reactant or a product. Kristen? Reactant. So if I'm decreasing the reactant, which way is it going to shift then, Trixie? It's going to shift to the left. Okay, and if it's shifting to the left, I want to counterbalance that by shifting to the right. Let it pull it out. So what am I going to do with my temperature? Decrease it. Decrease the temperature. Right.
How do you decrease the temperature for shifting away?
So when we look at an exothermic reaction, on your sheet there, you want to find the one, there's two of them, there's an increase and a decrease for exothermic. Which one tells you that it'll shift to the right, the increase or the decrease? The decrease. So then, this is why we're going to decrease the temperature in order to get it to shift to the right. Okay? You doing alright? This is probably one of more of the complicated versions because it's asking you to do more than one step. Alright, C. Is the increase the amount of hydrogen in the system? Hydrogen is reactant or a product? Courtney. Reactant. So which way is it going to shift then, Melissa? So then what am I going to do with my temperature? Increase it or decrease it, Theo? I'm going to increase my temperature because that's going to cause a shift to the left. Okay? That science is yours. Ready for the next one? 60. How would simultaneously decreasing the temperature and volume of the system affect these equilibria? Okay, so if we look at A, first things first, let's look at temperature. Is this an endothermic or exothermic? It's endo. And it told me if I decrease it. So if I decrease an endo, what's going to happen? Shift left. Okay, now we're going to look at volume. Again, I'm going to decrease it. Alright? This time I need to look at the number of moles, right? So how many do I have on the left? 0. Remember we wanted to look at the gas, right? Because solid isn't going to have that pressure volume. So I'm going to have 0 on the left hand side. And on the right hand side I'm going to have 1, right? Because we're just looking at the gas. Okay. So which side has more? My reactant side or my product side? Okay, so I'm going to say product for myself here. So when I look at the decrease of volume for a product, which way is it going to shift? Left. So if both of those items are happening, I decrease my volume and I decrease my temperature, overall what's going to happen? It's going to shift to the left. Make sense? I'm looking at what's happening with those two, they both say they're shifting to the left. So my system's going to shift to the left. Looking at B. If I look at, oops, sorry. We have a decreasing temperature, we don't know what it is. Decreasing temperature, and this one for B, is that an endothermic or exothermic? Okay, so when I decrease in exo version, which way is it going to shift? Okay. And this time we're going to do the same thing, looking at that volume of increase and decrease. How many items do I have on the left? 9. And how many on the right? So which side has more reaction to product? So which way is this one going to shift? Okay, so this time I have one shifting to the right and the other one shifting to the left. What is really going to happen? Nothing. They're going to balance each other out, or no effect. Mm-hmm.
So when you look at a chart, how do you know for like the number 16, how do you know which one to look at?
So you look at this one here and you look to see the volume. These two are saying decreasing, right? So then you look at to see if there's more moles on our side or reactant side. So because we counted them up, and there were 5 plus 4, that's 9. And over here there was 4 plus 6, which is 10. I'll accept that. Okay, so north plus 3. Okay. Oh wait, so 17. So looking at this one here, how many moles per liter of silver chloride will be in a saturated solution of silver chloride? Okay, so they gave us a KSP value. Okay. We are being asked about moles per liter, right? Or another one is a capital M, right? That's molarity, right? That's our unmet. Right? We don't know what it is. Okay? So, what we have then is we have to write out an equation. Since we only have silver chloride, remember that it's going to dissociate or separate. Okay. When we would Okay, so just to break it down a little bit better, we would have had our different ions, right? And if we look at this, this is a 1 to 1 to 1, right? Okay, so because it said saturated, remember that saturated is that QSP value? Okay, so our QSP plus KSP just as extra info. But when I look at this, it's a 1-to-1 ratio. So when I have my KSP, okay, and because it's a 1-to-1, I'm just going to call those X's, right, because they're the same. So I'm going to have X, then X, which is X squared, right? The KSP value I was given, so I should fill this in. Okay, how am I going to solve for my X then? Square root it. Okay, those are in here. So my 1.8 times 10 to the negative 10 square rooted as 1.34 times 10 to the negative 5 with a capital M or moles per liter, because remember we're finding that concentration. This one's going to have units. Because it's a 1-to-1, or it's a 1-to-1-to-1 really, they're all ones. My question was how many moles per liter of silver chloride will be in it, right? So you can have them separated. I'm lazy. So I just say that Ag is going to equal Cl, which I then ran out of room, is also going to equal that AgCl. Because they're all the same. They're all going to equal the same thing. So basically you need to remember, or a clue is when you see that GSP value, that you're going to put it in some sort of form like this. You need to always start with writing out the equation. Either a salt or your unknown. Usually it's pretty simple because it's going to be a 1 to 1 or a 1 to 2, something like that. Solve for your unknown, get your x, and then tell me what it equals. In the end, all it really asked for was silver chloride, which is just this one. But we added that those other two do the same thing. If you ask for more advanced or more on the question. So we're going to move on to 18, which is our last question, I believe. So, 6-liter vessel contains an equilibrium mixture of 0.222 moles, and a 0.0189 mole, and a 0.1044 mole. And we're being asked to calculate that KEQ. Because this one has told us all the equilibrium values, we don't need to do a nice chart, right? So, we do need to do a calculation though, because it only told us the moles. It didn't tell us the concentration, right? So how do we find concentration again? Or what's my units for concentration? Moles per liter or capital A. So, what do you think we're going to do? Moles divided by the liters. How many liters do we have? 6. So I'm going to look at each one separately. So my PCl3, the value that they gave us was 0.0222 moles. I'm going to divide that by my 6 liters, because that's how much we were told about. And I would solve that and find that it's 0.0037. Yeah. Then I'm going to do the exact same thing for my PCl5. Take the values that they gave us. Okay, so now I have my concentrations for my moles per liter. We're good? We understand how we got that right? So we took the moles that they gave us and we divided by the liters. Because that capital M stands for moles per liter. So that's all I had to do. They told us that it was in a 6-liter vessel. Okay? So now, what do you think we're going to do? Plug it into what? Right, there are KQ products over reactants. So, what are my products? Do either one of them have a coefficient or therefore an exponent? Okay, what should be at the bottom? Okay. Okay, so we just did what we normally do. They're all gases, so I can put them all in there. There's no exponents because they're all ones. What am I going to do now? plug in the values, right? So my PCL3, I'm going to take this number here, 0.0037, and I'm going to multiply it by my chlorine value,